Hello friends, welcome to this presentation where we are trying to understand the shear that is under transformation. Okay, so by definition we are saying a shear is a transformation in which points move parallel to the invariant line in such a way that the ratio of the distance moved by a point to that of the distance from the invariant line to that of its distance from the invariant line is constant. So the difference between a shear and a stretch is that with a shear, the movement is parallel to the invariant line. With a stretch, the difference with a stretch, the movement is perpendicular to the invariant line. Okay? Let's also take note. We are saying the invariant line is one on which the points on the object maintain their positions even after being transformed. Okay, so please take note that when you are dealing with a shear, the movement is parallel to the invariant line. All right, now how do you describe a shear? We are saying a shear, please take note here is this word shear here. A shear is fully described by stating the shear factor as well as the invariant line. You need to give a shear factor as well as the invariant line. Okay. Now, how do you get a shear factor? We are saying a shear factor is given by distance moved by the image point from the object point. So if you have maybe A here and A1, all right? So you're going to find the distance moved by this point from here. You find this distance by counting, all right? Then you need also to find the distance of the object point from the invariant line. Suppose this is the X or Y, and if our invariant line is the X-axis, all right, then you must find the distance moved by this point from here to there, then the distance moved by this point to that point. That's what we are saying here. Okay? There are these other things that we need to take note of, what we call shear matrices. There are times where you're supposed to find a matrix. All right? You can multiply a non-matrix by the object to produce the image. Or you can use this to say invariant line. When you know that the invariant line is y is equal to 0 or the x-axis, means that the shear is along the x-axis parallel to the invariant line. Then you are going to say, you are going to use this 1k01, all right, where this is a shear factor. Take note, when you are dealing with a shear, you have 1 here. When you are dealing with a stretch, you have zeros on the take note, this is a stretch. Here you have zeros, all right? But for a shear, here we have ones. The K is telling you about the shear factor. So if the invariant line is the x-axis, where where the shear factor is, that is the invariant line. All right? So the invariant line x is equal to the y-axis. So here where there is this, that is the invariant line. Okay? All right. Now let's look at these examples that we have here. Okay. I hope we are able to copy this. You can get a graph paper, copy it. All right? Pause the video, copy. Okay, copy that graph paper. Then these are the questions. All right? So you can pause your video, copy. So we have question 1, 2, 3. Then from 3 we go to 4, 5. So like I said, pause your video, copy this so that as we do it, you're able to follow. Okay, so we are saying triangle ABC is mapped onto A1, B1, and C1 by a shear. So this is mapped onto this one by a shear. A, state the invariant line. So how do we get the invariant line? Alright, to get the invariant line, you need to identify two pairs of corresponding sides. That is, from the object and the image. For example, maybe BC here, and you can go for AC. Try to extend some, try to create some lines, all right? So what I'm saying is you can get a ruler like this one. I say, okay, this is a BC. Of course, so I can try to create some lines here, dotted lines. I hope it is okay. I hope it is clear. All right. Then this is BC. The image is this one. So again, you do the lines. Okay, so this was BC. Then we identify its corresponding side, which is this one. So you can as well create some dotted lines, not until they intersect. So you have the first point of intersection here, all right? Then I'll go to another set of corresponding sides. Maybe I'll say AC, all right? So you can draw another line. All right, take note. So draw some dotted lines. This is very simple. Okay, so I've got that line here. Then its corresponding side or its image is this one. So even that one, I'll draw a line. Okay, draw a line. So they intersect. So you realize that they are intersecting here. Okay, this is the second point of intersection. The first point of intersection was this one. So you draw a line now, connecting this point and that point. So if you draw a line, you realize that when you connect these 2 points and draw a line, the line will be in the x-axis. The line will be in the x-axis. Okay? That's where the line is. So it simply means that for number 1, question 1, all right, A, so the invariant line is the x-axis, or you can say y is equal to 0. That is an equation. That is our invariant line. Okay, so now we know the invariant line. Okay, the invariant line is the x-axis. What is the second question? Find the shear factor. Find the shear factor. So we are saying to find the shear factor, we say the shear factor is given by, if we go back here, the distance moved by the image point from the object divided by the distance of the object from the invariant line. So we are going to identify maybe one point and its image, maybe C and its image. All right. So for us to find the shear factor, we'll say this is equal to what is the distance of C1 from C. Okay. So when you check here, this is 1, from here it is 1, this is 3, this will be 5, this will be 7, this will be 9, this will be 11, and the plus this one, it will be 12. All right, so you're going to have 12. Or if you want, you can say from here it is 2, 4, 6, 8, 10. Again, there's 1 here, 11, plus this one, 12. Okay, but now what is the distance of C from the invariant line, which is the x-axis? We know that from here, this is 2, 4. Okay, so we have got 4 here. 4. What is our answer? 3. So that is a shear factor. Alright, this is Roman numeral 1. What is Roman numeral 2? We have to find the matrix. Alright? Now, take note that we have said the invariant line is the x-axis. So here, to find the invariant line, we can choose. Are we going to use this one and this one? We are saying if it is the x-axis that is the invariant line, this is the shear matrix that we are supposed to use. 1K, 0, 1. Alright? So number 2, the matrix is equal to 1K, 0, 1. Right? So we'll have 1. What is our shear factor? 3. So here we have 3. Here 0. And this is the 1. Okay. Alternatively, you can say, let me multiply the matrix that I want to find, A, B, C, D, by the object. Right? What is the object? The object, you look at this one, the object, to produce the image. So you have got like A1, so you get the coordinates for A1, for A, B, C. You get the coordinates here. That is 1, 1, B, 3, 1, okay, 3, 1, then C, that's 1, 4, 4. This should give you get the coordinates of A1, B1, C1. You put them, then you multiply this matrix by that one and create the simultaneous equations. When you solve, you're going to get this matrix. You can try that. Actually, there's even a video on, I think, under stretch on how to get a matrix. You can even watch that one. You see how we demonstrated that. You'll still be able to arrive at that one. All right? So we can go to, I think, the second question. What is the second question? We are saying describe fully the single transformation which maps triangle ABC onto triangle A1, B1, and C1. Mostly this question is asked minus this. They'll just ask you this without asking you to get this. So you need to know how to describe. We are saying to describe, you must take the invariant line and the shear factor. So suppose you are just asked to say, this triangle is mapped onto this one by a shear, or just mapped, this one is mapped onto that one by a single transformation. Describe that. So you must know that it is a shear. So you write, then state the invariant line as well as shear factor. So in this case, would have said, okay, for the second one, for question 2, or to say it is a shear. You recognize, then you say shear factor is, what is our shear factor? We got 3. All right. You also give the invariant line is the x-axis, like we said earlier on. Now sometimes others will ask you to put direction, but the shear itself, the shear factor itself will tell you about the direction, because if it is positive, it's telling you where it is going. All right. If it is negative, again, it has its own implication, so you don't need even the direction, but that is enough. Okay. Then we go to number 3. Number 3. Triangle PQR is mapped onto P1, R1, and Q1, all right, by a shear. State the invariant line. So we must look at these triangles. You have got PQR, then P1, Q1, and R1. Now, when you look at these two, if you are not careful, you might think as if it is a reflection. No, don't be mistaken. It's not a reflection. Look, here you have got P here, all right? P and Q here. But check what is here. This is R1 and Q1. You don't have P as in P and Q. So, unless if there was a P here, maybe P1, Q1, then you think of a reflection. But here the letters have changed. So this is a shear, right? So now, how do we get the invariant line? The procedure is the same, okay? I'm going to find corresponding sides. Maybe I'll say Q and R are here, all right? Like that. Then you create dotted lines. Then I'll go to Q1 and the R1 because this side has been transformed onto this one. All right, so if you were to do the lines there, you have this. What you're going to have? You have this point of intersection, so they'll meet here. Take note here. Okay, then I'll go to another set, which is I'll look at my PQ, right? And this one. So PQ here for the image is this one. They have been transformed. So when you do that, you only create dotted lines. Okay, then I go to PQ. Okay, if I created dotted lines, okay, we'll meet here, all right? We'll meet here, but there's this line. So drawing a line here where there are these 2 points of intersection at 6 here and 14, it will take you to y-axis. So the invariant line is the y-axis. So the invariant line, this is question 3. Question 3, A. The invariant line is the y-axis, or x is equal to 0. Okay, so B. Let's look at the second one. Let's find the shear factor as well as the matrix. Okay, the shear factor. So we'll look at the shear factor here. So remember, we're saying the invariant line is the y-axis. So I'm going to pick one point. All right, maybe P and its image. I'm going to find the distance from P to P1. All right, when you check here, this is 2, 4. All right, so I'll write 4 divided by, what is the distance of this object from the invariant line? When you check here, it is 2. All right, 2. So when you divide this, what do you get? You get 2. So your shear factor is a 2. So we go to 3 where we need to get a matrix. So we are saying for the matrix, Okay, so for the matrix, we must either use this one or this one. But we are saying y-axis is the invariant line, so we are going to use 10K1. Alright? 10K1. Okay, so here we have 10. What is our K? K is 2. Here 1. This is the matrix. You can try to multiply, then you'll be able to get that. Alright? Number 4. Describe fully the single transformation that maps PQR onto its image. So, if I thought that was the question, okay, if that was the question, then where you're supposed to describe the single transformation which maps this onto that, you're able to see that this is a shear, so you write that it is a shear. Alright? Say it is a shear. Alright? Then you say shear factor is 2. Invariant line is y-axis. Okay, question 5 now. What is question 5? We are saying the matrix, this one maps triangle PQR onto triangle PQ2, P2Q2R2, which is not on the diagram. Find the coordinates of these. So what we are going to do, we'll say this matrix 1, 2, 0, 1 maps triangle what? PQR. Okay, what is PQR? Let's look at PQR. What is PQR? PQR. So when we look at P, it is 2,6. 2,6. Q 4,6. 6. Then R, it is 2,10. So 2,10. So the only thing that you need to do is to multiply here. So we are going to say this by that, that is 2. 2 plus this by that, that is 12. Okay? Then this by that, that's 4. Then 2 by 6, that is 12. 1 by 2 is 2 plus, this is 20. Alright? This by that, that's 0 plus. This by that, that is 6. 0 plus, 0 by 4 is 0. 1 by 6 is 6. 0 by 2, 0. Plus 1 by 10 is 10. Okay? So this is the matrix. So you're going to have 14, 6, 16, 6, 22, 10. Alright? Meaning that this is the first one. P2 is 4,6. Q2 is 16,6. And R2 is 22,10. These are the coordinates. It means you have fully answered that question. Okay, so I'm going to give you an exercise. So that is the exercise. You can copy and attempt. So that's how easy Shear is. Okay? Thank you so much. Please subscribe and share with your friends.